Hi friends, welcome to B.Tech. Now I am going to discuss some problems related to the jet transform. So in the previous class we discussed around 4 problems. Now we will continue those by 5th problem. Now take that 5th problem. Find the jet transform of x of n equal to a power n into u of n plus b power n into u of minus n minus 1. So here we have the standard signal a power n u of n and another standard signal b power n u of minus n minus 1, and those two are added. So by the linearity property, directly with the transform formulas we can write the jet transform. So for the a power n u of n, the jet transform is z by z minus a with ROC mod z greater than a. And similarly b power n u of minus n minus 1 jet transform is minus z by z minus b with ROC mod z is less than mod b. Now by the linearity, the jet transform capital X of z equal to z by z minus a plus minus z by z minus b, and the ROC is intersection of these two, that is mod z greater than mod a and mod z less than mod b. Then we have the x of z, which is z of a minus b by z minus a into z minus b with the ROC mod a to mod b. So here always this mod b value must be higher than mod a. If mod a is greater than mod b, then there is no chance to have the intersection of these two ROCs. That's why for that case we can say the ROC doesn't exist. So for the existence of this type of two-sided sequence, the ROC will exist whenever the magnitude of b value is more than the magnitude of a, and that we have to show in the ROC figure. And come to the next problem. Find the jet transform of cos omega naught n into u of n. And here by the Euler's identity we know we can write cos omega naught n as e power j into omega naught n plus e power minus j omega naught n by 2. Now we can write this cos omega naught n with the multiplication of exponentials. Then there we have the e power j omega naught n u of n term and e power minus j omega naught n u of n term. And now in this case also let us use the standard formula. A power n u of n jet transform is z by z minus a with ROC mod z greater than mod a. So using that, here a is nothing but a power j omega naught. Then mod a means mod of e power j omega naught, which value is 1. So we can write e power j omega naught n u of n jet transform as z by z minus e power j omega naught with ROC mod z greater than 1. Similarly, e power minus j omega naught n u of n jet transform, which is z by z minus e power minus j omega naught with ROC mod z greater than 1. Now by combining these two by the linearity, cos omega naught n u of n jet transform is 1 by 2 of z by z minus e power j omega naught t plus z by z minus e power minus j omega naught. Now on simplification, we can get the jet transform, which is z square minus z cos omega naught by z square minus 2z cos omega naught plus 1 with ROC mod z greater than 1. So this is the jet transform of cos omega naught n into u of n. Similarly, by taking Euler's identity, we can get the jet transform of sin omega naught n u of n as z into sin omega naught by z square minus 2z cos omega naught plus 1. See here in this case the denominator is same. For the cos we need z square minus z cos omega naught. For the sine we have the z into sin omega naught, and both the cases the ROC is mod z greater than 1. Now come to the next problem. Determine the jet transform for the analog input signal x of t equal to e power minus at applied to a digital filter. So here the question is to find jet transform but given x of t. So to apply the jet transform, remember the sequence we need to obtain. So for that we have to sample this with the sampling interval n into ts. So after that we have the sampled signal of the x of t, which is e power 0, e power minus at, e power minus 2at and so on. Here t is the sampling interval and all these are the sample values of the causal sequence. Now by taking for that causal sequence the Z transform sigma n equal to 0 to infinity x of n into z power minus n, and there x of 0, x of 1, x of 2 we can obtain from this sequence as e power 0, e power minus at, e power minus 2at and so on. We have the form 1 plus e power minus at z inverse plus e power minus at whole square z power minus 2 plus and so on up to infinite. Now it is like GP infinite series form. So there we can use the formula 1 by 1 minus r with mod r less than 1. So we have 1 by 1 minus r value e power minus at into z inverse with the possibility mod r less than 1, that is mod e power minus at into z inverse less than 1, or mod z value must be greater than mod e power minus a into sampling time period t. Therefore, the x of z for that given continuous time signal applied to the digital filter is z by z minus e power minus 8 into capital T with ROC mod z greater than mod e power minus a into capital T. And similarly, you can practice at your home the Z transform of the sequence x of n, which is 2 power n for n less than or equal to 0, 1 by 2 whole power n for n positive values, for n even values, and 1 by 3 whole power n for n odd values. So for this sequence, take the direct definition and there split the x of n sequence for n less than 0, for n even values, for n odd values. There we have the total 3 different series summation and evaluate separately those, and then we have the corresponding Z transform, which is the sum of those 3 sequence Z transforms. And they remember the ROC is the combined part of those 3 Z transforms. Thank you.